Hello geometry students, my name is Jami Emigh, and this video is our discussion on sections 11.4 and 11.5, volumes of prisms, cylinders, and Cavalier's principle, and 11.5 volume of pyramids and cones. Volume is the space that a figure occupies. It is measured in cubic units, such as cubic inches, cubic feet, or cubic centimeters. I always visualize a little cube like this when I'm calculating volume. And so if I have an answer of something like 500, let's say centimeters cubed, then I picture this visually. This is a 1 centimeter by 1 centimeter by 1 centimeter cube. So it would take 500 of these to fill the space of whatever it is I was calculating and got that 500 centimeters cubed for. All right, a theorem, Cavalier's principle. If two solids have the same height and the same cross-sectional area at every level, then they have the same volume. And we'll practice with that soon. Okay, the volume of a prism is calculated by finding capital B, which just like last section is the area of the base, and multiplying that by lowercase h, which is the height of the prism. Sometimes I think about it as, just to give you a little visual, I find the area of this base first, okay? That's two-dimensional, so that one cross-section like that, and then it starts to fill up. So volume takes on that third dimension. And as this solid fills up, so you can see all these cross sections when it gets to the top, so basically capital B multiplied with lowercase h, then we have the volume. All right, let's try this example. What is the volume of this rectangular prism? We start by writing our formula. I highly recommend you write it in that general form right there. And then let's slow down a little. We need two variables, two blanks to fill in. First one is the area of the base. And I'm going to use this here as the base. And that is the two-dimensional rectangle. And so the area of a rectangle is base times height. So that would be 20 times 24. And then this right here would be the height, lowercase h equals 10. So filling those in would look like this. Then we do our simplifying, and it turns out that it would take 4,800 cubic centimeters to fill that rectangular prism. All right, let's try this one. What is the approximate to the nearest cubic inch volume of this triangular prism? Okay, so same thing. Let's start with our general form. And we know that the base this time is a triangle. So let's focus on this two-dimensional triangle right here at first, okay? So to find the area of that base, that triangle, you can do its base, so lowercase b, times its height would be this distance right there, the length of that altitude. Okay, so we need to find that height. We can find that height by breaking this down to special triangles because, make that go away for a second. We know that this is an equilateral triangle, which means that it is also equiangular, which means that its angle measures are all 60 degrees. So when we cut it with that altitude in half like this, we end up with a 30, 60, 90 degree special triangle. Okay, let me draw that 30, 60, 90 a little clearer over here now. We only have half of the base now, half of that 8, that gets cut in half, so we have 4 there. Here's our 30. So across from the 30 degree angle, we put an S, and across from the 60, we put S radical 3, and across from the 90, we put 2S. Okay, writing an equation with an S in it would come from right here, S equals 4. and that makes our height. A lot of writing on here, sorry. This right here is our height of that triangle. We're not talking of the pyramid right now, prism right now. So the height of this triangle would be 4 radical 3. Okay, so to find capital B, or the area of that two-dimensional triangle, we would need to do base of 8 times height of 4 radical 3, and it is half of that. Okay, I'm going to erase all that. Show you what it looks like. There it is, typed up nicer. And that right there is 16 radical 3. That would be square inches to fill this base right here. And then we multiply that by the height of the prism, giving us approximately 277 cubic inches. Okay, volume of a different prism. This prism has a very specific base. It's a circle, so we don't even call it a prism. It gets its own name. It's a cylinder. And to find the volume of a cylinder, it's the same as the prism, base times height. But we know that the base is always going to be a circle, and you guys know that the area of a circle is pi r squared. So that's why whenever you're asked to find the volume of a cylinder, you're going to want to use volume equals pi r squared h. Okay, so make sure you write this formula down. You can see it's dependent on radius and height. Let's try this example. What is the volume of the cylinder? And they want us to leave the answer in terms of pi. General form, volume equals pi r squared h. We need to plug in the radius, which is 3 centimeters, and the height, which is 8 centimeters. Looks like that. And leave it in terms of pi, okay? So it's 72 pi, and that would be cubic centimeters. A composite solid is a 3-dimensional figure that is a combination of 2 or more simpler figures. We can find the volume of a composite solid by adding the volumes of the figures that are combined. So if it's a funky looking figure, just like when we had surface area, it's like, well, what's the formula for the shape of this thing? We're like, well, we don't know. We don't have a formula for that shape. So we cut it into shapes that we do know, and then we add the surface areas together to get the total area, surface area. It is the same thing with volumes. Break it into solids that you do know how to find the area of, and then just add them together. Like this one right here. What is the approximate volume of this bullnose aquarium to the nearest cubic inch? All right, so we have got 2 figures. Well, it's one solid, but if we break it right where they have that diameter line, then it looks like we've got this one right here, a rectangular prism, and then this right here is half of a cylinder. Okay, half of a cylinder, so careful of that. One thing, let's see, we've got 24 inches there, 24 inches there, so our height is 24 inches, and now we have, this one was not quite so easy to spot, but the diameter, should that have been a full cylinder, was 24 inches, so that makes the radius 12 inches. Okay. Let's do the volume of the prism first. Capital B times lowercase h. Capital B, 36 times 24 for that rectangle, and then multiply it by the height of 24 inches. Gives us 20,736 cubic inches. Now let's do the volume of half the cylinder, which is pi r squared h, but then half of that, so either divided by 2 or multiplied by half. So plugging in r is 12 and height is 24. Gives us approximately 5,429 cubic inches, giving us a total volume, being their sum, 26,165 cubic inches. All right, 11.5, title is Volumes of Pyramids and Cones. Volume of a pyramid. we have this derived formula for us. You can always look up the proofs of these, you guys, online. I'm just not taking the time to put them on these, but you can find any of these formulas, the nice formal proofs with nice videos on the internet. Okay, the volume of a pyramid is 1/3 the volume of a prism. Okay, so what I like to think about it like this. If I were to take the corresponding prism, so basically I'm going to make a second congruent base, and I'm going to connect like this. Okay, so that would be if this pyramid went straight up. It didn't go to a point. If it just went straight up to another parallel base, it would then be called a prism. So take that volume of your prism, which is, as you guys know, capital B times lowercase h, but that's too big, right? We have to shrink, we have to have less than that. And it's actually exactly 1/3 of that. So either divide by 3 or multiply by 1/3 of the volume of that original prism. All right, the entrance to the Louvre Museum in Paris, France is a pyramid with a square base and a height of 21.64 meters. Okay, so we have a square base. It's like the side of our square is 35.4 meters long. And we're asked the approximate volume of the Louvre pyramid to the nearest cubic meter. Formula is 1/3 base times height, area of the base. All right, our base is a square, they told us. And you guys know the formula for the area of a square. You just take one of the side lengths and multiply it by itself. Area of a square is side squared, like that. So that's why you see 35.4 times 35.4. And then you multiply it by the height, which was given to us in the directions here, height. And that rounded to the nearest cubic meter would be 9,039 cubic meters. All right, let's try this one. What is the volume in cubic feet of a square pyramid? Okay, square base again, with base edges 40 feet and a slant height of 25 feet. Okay, let's find the regular height first because the formula is dependent on it. Formula is 1/3 area of the base times the height. So let's find lowercase h first. And we can do that by zooming in on this blue triangle inside of there. This triangle is half of the base edge, so it's 20 feet, hypotenuse of 25 feet, and so we're looking for the other leg. So we do 25 squared is equivalent to h squared plus 20 squared, which gives us the height of that triangle at 15 feet. Okay, so this pyramid is 15 feet tall, and we know that its base is a 40 by 40 square. So we plug those in. And let's see, were we asked to approximate? What is the volume? They didn't say anything about approximating. Oh, this was a nice even number anyway. It is 8,000 cubic feet. Volume of a cone, same thing. Think of that cylinder, if you will. So the original cylinder would have looked something like this. But you can see the cone there takes up less space than that. It takes up exactly 1/3 of that space. So your volume of a cone formula is your volume of your cylinder, which is pi r squared h, and then multiply it by 1/3. Let's try this one. The covering on a teepee rests on poles that come together like concurrent lines. The resulting structure approximates a cone. If the teepee pictured is 12 feet tall, okay, so we have a height of 12 feet, with a base diameter that is 14 feet, what is the approximate volume to the nearest cubic foot? Formula is 1/3 pi r squared h, so we need to plug in r and h. Be careful, r is not 14, r is half of 14, 7. And they are asking us to approximate this, so you can pick your calculator up and use that pi key. Don't use 3.14 unless directions specify to do so. Use the pi key on your calculator. And we get the volume of the teepee is approximately 616 cubic feet. What is the volume of an oblique cone? Give your answer in terms of pi. All right, same formula. All right, doesn't matter if your cone is oblique or right. Same formula, 1/3 pi r squared h. So using our height of 25 and our radius of 15, and this time we are asked to give our answer in terms of pi. So don't pick up that pi key. Don't use that pi key on your calculator. Leave it alone. It's 1,875 pi, and that units would be cubic feet. All right, that will conclude our discussion on Chapter 11. My name is Jamie Emigh. Thank you for joining me, and I will see you next time for our discussion on Chapter 12.